Okay, so what I want you to notice first is, okay, so let's suppose that we have, I'm gonna start with the use up and I'm gonna like explain what it does and then I'm gonna move to parts. Okay, so let's suppose we have this. Actually, no, I'm gonna make it harder. Okay, then its derivative would be 3 secant squared 3x, right? Okay, so then from here to here we took the function's derivative, but if we had been given this, and if we had to like go back and like figure out what function gave us this derivative, then we would take the integral. So then what you do with use up, you basically, it's like undoing the chain rule. So use up, undoing chain rule. And I'm gonna show you why that is. Okay, so if we set u equals to 3x, does that make sense? So use up is just undoing the chain rule. And why I wanted to point that out is you're gonna use the same idea for integration by parts. Okay, how do we here? So let's suppose you have two functions, okay? So we're gonna call them u and v. Now, if you differentiate both functions, so how would you take the derivative of the functions being multiplied? Well, so you would do u times the derivative of v, so dv, and then v plus the derivative of u. Oops. Okay, now you took the derivative of u times v and you got this, but now let's say that we wanna undo that derivative. So then you would integrate the function, right? Because like the derivative and an integral are like opposite operations, so like plus or minus, they cancel each other. So if you take the derivative and then you integrate it, you cancel that out. So then here you would cancel the derivative with the integral, so you will have u times v. And here you took the integral of this entire function, so then you can say integral of u dv plus integral of v du. Okay, and now let's solve for this. So if we solve with integral of u dv, we have uv minus v du. So this is where the formula comes from. Yeah, I personally don't have this memorized. Like I always, when I use integration by parts, I always have to derive it. Yeah, so you know, if you're not good at memorization like this, this is a good way to just do it quickly if you forget it on a test. Okay. Now, okay. Now let's integrate this function. And then you might think, okay, that's easy. That's 1 over x. Maybe that's what you thought. But it's actually okay. So if you differentiated ln x, you will get 1 over x. So the integral of 1 over x is ln, and you put absolute values. I'm not going to explain why here because I want to make this a quick video. But you would put absolute value for the x. So that's where so here this is the integral, and here's the antiderivative. Here we have the integral ln x dx, and we want to find what that's equal to. So we want to find its antiderivative. Okay, how will we do this? Well, we're gonna use this function, this formula I mean. Okay. So I'm gonna say that u equals this, right? U equals ln x, and dv equals dx. You're gonna see why I just did that. Okay, let's see. Now, if you differentiate the u, then you will get 1 over x dx. And if you integrate the dx, so if you have this, what's that? That's just x plus c basically, but it doesn't matter for integration by parts. You're gonna see why. Like basically it cancels out with, I'm not gonna explain, but it's just x. Okay. Okay, so then we have u and v, right? U and v. So then that would be x ln x minus, well, what's v? V is x, and du is 1 over x times dx. When you integrate, you have to have that dx over here, because basically what you're doing is this. And then you are multiplying the dx to the side. Okay. So now that we have this, well, this we can integrate, right? Because the x is cancelled out, so you have integral of dx. And now here, that's when you're gonna have your c. Okay. Basically, you had a c over here, but then you are gonna have another c when you integrate. So in the end, you're gonna combine those two constants, and they're gonna be another constant. Okay, hopefully that made sense. Now I'm gonna give you another example. And this is like another case, another thing that might happen when you use integration by parts. Okay, so if you have the integral e to the x sine x dx. Oh, and also, okay, so I forgot to mention, but what I always do is I make like, you saw like this list. I put u in dv, and then I say, okay, what's the integral of dv x? What's the integral of du, this? And also, something that I want to point out. I chose, okay, so here it matched, right? You had u, and then you said, okay, u equals ln x, dv dx. But sometimes you're not going to have it in this order. So you're going to have to see, okay, which of the two functions can I differentiate, and which of the two functions can I integrate? So in this case, you knew the derivative for ln x, so that's why you chose ln x to be u, so that you could calculate du. Here you knew that the integral for dx, so you chose it to be dv, so that you can integrate it. Okay, so we're gonna have u, and in this case it's gonna be the same. You're gonna use e to the x because you know the integral for e to the x. That would be e to the x, and you also know the derivative for sine x, but you're gonna see why we didn't make that choice. Why we chose sine x dx to be our derivative, our integral, I mean. Okay, now when you integrate sine x dx, what do you have? Well, you have negative cosine x plus c, like I said, but then you're gonna get another c and they're gonna add up, and yeah. Okay. So it's actually negative cosine x, because when you differentiate cosine x, you get negative sine x. So then you have to make that a negative over here first, so that when you take the derivative, you have negative times negative sine x, and you get a positive sine x. Okay, so then I'm going to use my formula that I have over here, uv minus, I'm just going to write minus v du. So u is going to be e to the x, and v is going to be negative cosine x minus, oh, okay, so minus negative cosine x, so that's going to be a positive. And then your du is e to the x dx. Don't forget that. Okay, now I'm gonna just rearrange my terms. And then you're gonna see that we have to do integration by parts again. So we to integrate this, and you're gonna see what happens. Okay, so I'm gonna do this quickly. Negative e to the x times cosine x plus the integral for this, which is uv minus v du. So uv, that's minus v du minus v du. So this. But now I'm gonna write it again over here. Look what you have here. E to the x times sine x dx. And here you also have e to the x times sine x dx. So what you can do is you can say, okay, I'm gonna move this to the other side. I'm gonna cancel it out on this side. I'm gonna add it on this side. So then this is 2 and don't forget that you have this also, plus e to the x sine x. Okay, and then you divide by 2. And that's it. Okay, so you're just gonna have to like try it multiple times. Or wait, let me see, maybe there's another way. Yeah, you know, like experience is gonna be your best teacher on which method you're gonna have to use. But yeah.